Okay, so I don't think I even need to read that whole stuff. I was just now browsing through the Wikipedia and I just found these guys. I just found these. Which I mean, it makes sense. Yeah, it's kind of like in a way what I was thinking, right? So I was looking at the complexities and remedies, and I mean the thing is the number of possible outcomes is very large, and that's true because we're working off of a large dictionary, 26,000 something, right? So exactly, millions of possible words. In our case, it's even like it's just a two examples. So it's like 20 something, right? So this can make the calculations for the softmax layer, for the multiplication of the softmax function itself, condition expensive. Okay, but that's not what I meant. I don't care about how complex it is to compute. Like yeah, that's what I meant. So it's more the gradient descent method. It was calculating the softmax for every training example, and the number of training examples can also be large. Not effort. Okay, that's not what I wanted to do. A person that reorganized the layer for more efficient calculations with the hierarchical software and the differentiated softmax. Binary tree structure. Latent variables, the desired probability, softmax value of a leaf outcome can then be calculated as the product of the probabilities of all the nodes. Trees balance, okay. Approximating the sun, this. Okay, but it didn't tell me. That's not what I meant. The point is, maybe I'm using this wrong. I mean, like ypred is the, so this is really what I'm deriving, right? With respect to W2, am I using this correctly? So I am calculating the gradient and then the gradient the sort of the gradient function here, right? The thing is, what is the thing, right? So how do these logits even look like? When we do the forward pass, and let's try to kind of like get rid of some of these things. When I do the forward pass, forward objective, the forward pass, we do these probabilities in here, right? So let's try to print these for a second. These are big vectors, right? But x is not defined. Oh, sorry. Let's click on x. The thing is, as you can see, right? I mean, there's a lot of zeros. Can I wanna, okay, so let's let's print the max. Forward pass. Does NP have something called max? I guess so. Let's see how this works. That's what what the hell? Is that a problem? Is that just like me having bad luck? Wait. What does NP max do? Can I flatten it somehow? If I have multiple dimensions, I wanna. That's not what I mean, bro. Stop. Like, I'm just asking you something. Like, axis 1 maybe. Can I do something like this? Does it work? Wait, why is it printing? Oh, what am I doing? Bro. Sorry. That's all we want, right? Props. Why? What is the problem? What is the problemo? So no, I mean there's a high number, yeah. There's the okay, yeah, that's true. There's a number. There's like a 0 point, you're 0 point something. That's fine. So there is some sort of like high number that is being returned in some cases with that's all good. So I guess that's a lot of zeros. Can I count, so NP count values above a threshold? Okay. Really? Really? You can just compare that? That's pretty cool. So can I just let's see if that gives us something useful. I hope it's not going to print the whole. You probably want to add some. because I'll just count the zeros and ones, I guess, just by. Really? Really? Is it that spiked? That is interesting. I don't know if that's, I'm not doing the right thing, but is this counting it correctly? Above threshold. So is this correct? Let's see. I think that it's doing the correct thing. I just want to make sure. Sometimes the way that you're passing things to functions like print, I just don't tend to kind of believe that much. But yeah, 1101. That's weird. Okay, so the threshold being 0.5. I'm trying to, what I'm trying to get at is, why isn't it working? So there's. Why is the derivative of this? Okay. Fine. No, return. Softmax. Okay. Why does the derivative of these doesn't work? Okay. So it's the forward pass. Then we have this objective function with respect to W2. But this still doesn't fucking work for it doesn't, right? Let's just do this again. I think it doesn't. I should change it. I think it should just be 0 again. Props. How come so? Logics. So, like, okay, so it's doing this thing, fine, but like why is it not working? So how does the derivative of the softmax function look like, right? If the softmax function I can't. I'm just thinking. I'm just trying to think. How could I do this visually or intuitively? The problem is I can't, because actually it's not. It's not so easy, because I can't just visualize it and then tell you what the derivative is, because the input is an array. Sorry, the input is an array. So how to implement the derivative of the loss function? The derivative of the loss function. Why? What is the problem with these? I'm just banging my head against the wall, right? So we've got a softmax function. What is the derivative of the softmax function? Okay, let's see. I think that's finished actually. But it's just gonna be flat. It's just gonna be fucking freaking flat. It's just flat. It's just damn flat. It's just damn flat, and AI. So How does the derivative of the softmax function look like? Weights, loss versus cascading gradients, the loss is often used in the uplands, and its derivative is crucial. Question room. Three logits. Each partial derivative in the form of matrix. Okay. So the derivative of the softmax function is not a single value, but a matrix Jacobian. Each entry in the matrix represents the rate of change of one softmax output with respect to one output value. This matrix is crucial. I understand, but in this you can better grasp how now. No. Sure. Can you? So, in what language is this? This is in LaTeX, right? Like. Yes, not a simple function. It was some matrix calculus. But how does then grad account for these, right? Thus, so do functions like grad from autograd work well with softmax? Like I why wouldn't it, right? So maybe I would need to understand why. Okay, I mean, actually, that's not a bad idea. That's definitely not a bad idea. Where was that thing? Test grad. Test soft. So no, okay. I thought I was not. I thought I didn't have this proper return in here. Test soft. Okay, let's try that. Test soft. Test soft. Python. Okay. I mean, I don't know what am I trying to prove with these. I mean, what if they are very small values, like, and one is like very big, right? What if I do these? Still works. It still works. Softmax. What is softmax defined like that? Softmax. I don't know, man. I'm still stuck on this. I have to figure it out. I'm stuck because why am I getting like mostly zeros when I remove the softmax? Then it doesn't. That's what I can't understand. When I remove the softmax from the objective function, I don't know, man. I'm just pretty stuck. Just pretty stuck.